the discriminant okay, put that up there. All right. Right. The general form of a quadratic equation is ax squared plus bx plus c equals 0. And the discriminant of an 4ac. So in this particular case here, a is 6, b is -2, and c is -3. And therefore the discriminant is b squared, so that's -2 squared. Take away 4 times 6 times -3, which is 4 plus 24 times 3, which is 72, so 76. And here, 1 squared minus 4. Just write it all out in brackets like that. 1 take away 8. So -7. Now, what's the discriminant used for? Well, if it's less than 0, then the quadratic equation has no real roots. And if it's equal to 0, it has exactly one root, often called the root or a repeating root. And if it's greater than 0, then it has two real roots. But if you allow yourself to have complex numbers, then if it's less than 0, it actually has two complex roots, and they're complex conjugates of each other. And as a reminder about what that is, A at BA, the conjugate of that is for A plus BI, the conjugate of that is A minus BI. Okay. Okay, next. B squared, so -14, take away 4 times A times C, so 16 plus 80, so 96. This one, 1 squared minus 5 times -2, 4 times 5 times -2, so 41. B squared minus 4 times A times C, so 25 take 8, so 17. B squared minus 4AC, so 25. Add 32, so 57. Find the discriminant of each quadratic equation, then state the number of real and imaginary solutions. Okay, so this is applying the knowledge that I just laid out. So b squared minus 4ac. So -3 squared minus 4 times 9 times -8, which is 9 plus, and then we'll do 72 times 4, so it's 288, which is 297. So it has two real roots. B squared minus 4ac applied to this. So -8 squared will take 4 times -2 times negative. Uh-oh. Whoa. Did you see that? I was running on autopilot, so I didn't even see that. Oh my goodness. But I caught it. -10 is over here. It's supposed to be equal to 0. Okay, let's fix things. So 9n squared, take 3n, plus 2 equals 0. Now, apply b squared minus 4ac. Okay. 3 squared minus 4 times 9 times 2. Okay, so this now becomes 9 minus 72, which is negative 63. So, no real roots. I don't know what they actually mean, though, by number of real and imaginary roots. 2 complex conjugate roots. Look, show you what I mean by that. Okay, that's not going to load. Okay, I'll just apply it here. So we want to solve this. So minus 3 plus or minus square root negative 63 all divided by 18. So that's equal to 3 over 18, which is 1/6. That. Okay? Complex conjugates. And anyway, root 63 is 3 root 7. So we cancel out on the bottom. There, like that. So it's like a 1/6 of 1 plus or minus root 7i. Just there, like that. Anyway, now we're going to correct this. So, first set it equal to 0. Negative 2x squared, take 8x, take 8 equals 0. Then apply b squared minus 4ac. So one real root repeated. 9m squared at 6m at 6 equals 5. Take 5 from both sides. B squared minus 4ac. 4 times 9 times 1. And here, delta, the discriminant rather, b squared minus 4ac. So that's squared minus 4 times 4 times 4. Next. Okay. (64) take 288 is negative 224. So two complex conjugate roots. Negative x squared takes x, take 9 equals 0. The d discriminant is b squared minus 4 times negative 1 times negative 9. 36, take 36 equals 0. So one real root. Take 6 equals 0. Discriminant. And here. Find the discriminant and then state the number of rational, irrational, and imaginary solutions. Okay, so the discriminant can also reveal the nature of the solutions. If the discriminant equals k squared, for some natural k, then the roots are integers. But I guess you could extend it so that if k were to belong to the integers, then the roots would be the Gaussian integers, which are, complex numbers. So numbers of the form a plus bi, where a and b are both integers as well. I guess that could work. So let's apply it here. So first, just rearrange things so that it's all set equal to 0. So negative 6x squared plus 7x plus 3 equals 0. Write down delta for discriminant. It'll be 7 squared minus 4 times minus 6 times 3. So that's 49, and then plus 72. And that's equal to 121, which is a perfect square. As 121 equals 11 squared, x1 and x2 are rational. Oh, beg your pardon. I said integers over there. I meant to say rational. Four k squared at 8k at 4 equals 0. Oops. Discriminant. K squared at 2k at 1, so k at 1. negative 7n squared at 8n equals 0. The discriminant b squared minus 4ac, so 8 squared minus 4 times negative 7 times c, which happens to be 0. So 64. As 64 is a perfect square, it has two rational roots. Bring to one side, find the discriminant. So, two real irrational roots. Because if you imagine the quadratic equation, we're taking the square root of 140, which is not a perfect square, and therefore, when we evaluate it, it's not going to be a perfect square. Negative 10n squared. Take n, take 9 equals 0. The discriminant, that's b squared minus 4ac. And that is 1. Take 360, which is negative 359. And that's not a perfect square. So two complex irrational roots. Negative 8r squared. Take 9r at 8 equals 0. Apply the discriminant. Negative 9 squared times 4 times negative 8 times 8 equals 81 plus 64 times 4, which is 256, which is 337. It's not square. Two irrational real roots. Just two more. 5p squared at 10p at 5 equals 0. Find the discriminant. It's 10 squared minus 4 times 5 times 5. Like that, so that's 100. Take 100, which is 0. So one real root. In particular, I'd like to exhibit this for you. I'm going to factor out 5. P squared at 2p at 1, 0. And this is the same thing as 5 times p at 1 all squared equals 0. So p is negative 1. Here, negative m squared at 5m equals 0. Apply the discriminant. So that's b squared minus 4 times a times c, which is not equal to 0, beg your pardon. It's actually equal to 25. It has two real roots, and indeed if I exhibit them to you, you can just factor out m. So, namely 0 and 5. Write a quadratic equation that has two imaginary solutions. Okay, you know my style. I like to go with the simplest one possible, or the most sort of like perfect looking. So I'm going to just say x squared there. And those are indeed imaginary. In your own words, explain why a quadratic equation can't have one imaginary solution. Well, say that the discriminant is negative. Like, what do you mean imaginary solution? Do you mean complex number? Yeah, and the other one is like a real. Well, I'll show you how that can't be possible. Okay, so I've got x take r. I put it in factorized form. I mean, it's just obvious. I wonder what they've said. I mean, answers vary, yeah, but like, just look at the quadratic formula. You know, it's pretty obvious. It's like these 1 + 1 = 2 things. Okay. Find the value of c that completes the square. So when we factorize, just looking at the first two, like, okay, let's do it in general. X squared at bx at c. I want to complete the square. Okay, so first I've got to divide everything through by a. Because really completing the square applies to like a monic quadratic. Then what I want to do is I want to divide this by 2. I'm going to have x plus b over 2a, just there like that. And then if you think about it, when I square this out, I'll have b squared over 4a squared, and then b squared over 4a squared is multiplied by a, so I'm going to have ba over 4a squared. So I'm going to have b squared over 4a. B squared over 4a. And I've got to take that away. To keep the books balanced. Yeah. Anyway, let's find it here. So, my mind says x at 3 all squared, and when I do that, I've got, it would simply be 9. Let's check if these are right so far. 9, 25, 289, 256. So imagine that. You square x, take 25 over 26, and that's how you recover that term right there. Okay, now we must solve these quadratic equations by completing the square. So, what do they mean by this? Okay. Do that. Then take the square root of both sides. Yeah? And move over the 7. (59) on the right, v add 3 all squared on the left. So minus 53 plus or minus root 59. (51) on the right, a add 7 all squared on the left. So minus 7 plus or minus root 51. (11) on the right, x takes 6 all squared on the left. So the square root of (11) plus the 6. So 6 plus or minus the square root of (11). So in other words, 6 plus or minus root 11i. Wonder if they express it that way. Well, wait. What's going on? Am I being foolish? I think I am. Wait, let me correct myself. Minus 11 on the right. X minus 6 all squared on the left. Okay. Right. Not sure. Well, Just clean things up. Oh my goodness me. Oh my goodness me. See what happens when you're not paying full attention? Right, okay. Start again. There's no problem. Just sometimes it happens. So, take it slow. P squared of 14p equals 38. Then square it out. Complete the square rather. So it'd be p add 7 all squared. But then we have to balance the books. So take away 49, and that's equal to 38. Now you have to add 49 to both sides. So it's p add 7 all squared equals 87. Then you take the square root of both sides, and then you take 7 from both sides. So p equals negative 7 plus or minus square root of 87. See? Can happen to anybody. Concentrate, concentrate, concentrate. Okay. 59 on the right. V add 3 all squared on the left. Minus 9 on the left, keep the books balanced. Move that over to the right. So 59 add 9 is 68. And then square root that and take off the 3. So v equals negative 3 plus or minus root 68. Which is 2 root 17. I didn't know they wanted it like that. So yeah, much better. Much better. Okay, fine. Sorted. Okay. $51 on the right, x at 7 all squared on the left. You've got to take 49 to keep it balanced on the left. So add 49 to the right to keep that okay. So that's 100 on the right, and then square root of that. So that's plus or minus 10, and then take away 7. Minus 7 plus or minus 10. So that's negative 17 or 3. Negative 11 on the right. X takes 6 all squared on the left. Take 36 to keep it balanced. So add 36 on the right. So negative 11 and 36, that's 25. Square root that, that's plus or minus 5. And then add the 6 over, so 6 plus or minus 5. Plus or minus root 5. For this one here, I mean, this is obviously x at 2 times x at 4, right? So I just know that it's going to be minus 2 and minus 4. But following the procedure, minus 8 on the left. Speak better. Minus 8 on the right. X at 3 all squared on the left. Take 9 on the left to keep it balanced. Move that 9 to the right. So negative 8 at 9, that's 1. And then plus or minus 1. And then 3 plus or minus 1. So it's exactly as I said. Minus 3 plus or minus 1. Yeah. Here, 3 on the right, on the left. Take off 1 to keep it balanced on the left, so add 1 to the right to get to where we want to be. So 3 add 1 makes 4, square root that, plus or minus. So it's going to be 1 plus or minus 2. Which is -1 or 3. Okay, a bit faster now. X at 7 all squared equals... Well, maybe it'll get harder to say. Now move it over. So 64, root that, plus or minus 8, minus 7 plus or minus 8. So that's equal to minus 15 or 1. Six all squared takes... What's 36 take 23? Well, that's 13. So root plus or minus root 13. So 6 plus or minus root 13. So move that 91 over. So 98. And then you've got to take out the 4 here, but add it over there. So 98 add 4, so that's 102. So square root of 102, which is 2 root... Oh, why am I not getting this? It's 2 times 3 times 17. So you can't do it. So that, I think. Okay, take 26 from 8. So negative 18. And then we have 25, negative 18. And we've got to add 25 onto that, so 7. So x is 5 plus or minus root 7. So here, minus 6 on the right. Minus 6, and then add 4 to it, so minus 2. So k is 2 plus or minus root 2 times I. Oh, yay. Okay, so All right, finally a non-monic. I divide everything through by 5. There's 16, so plus or minus 4. Divide everything through by 6. And take 1, add 1, so 9. So divide everything through by, well, you can do 2. Yeah. Do that. So When you square it out, you get a quarter over there, but I want to take up a quarter to keep it balanced, and then I want to add a quarter over to there. It's going to be that. Minus half. Plus or minus 35. Yeah, you can simplify that. Root 35 over 2, if you so wish. But I do not so wish right now. Can't believe I made that mistake at the very beginning. It happens to everybody, but, you know, what a travesty. Let's just divide all that by 7. Let's just do that. Know what I mean? Oh. On the right. Okay. 8 over 7. And then what's 700? Take 64. 636. So this. And 636 though feels like 121, but it's not. It's 106 times 6, and 106 is 53 times 2. So you can't go any further with that, except for rooting the denominator, which is not what I want. 10p squared over 4p at 77 equals 9. So I'm going to take away 77 from both sides. So I'll have, as a result, negative 68. And then I'm going to half everything. 5p squared add 2p equals negative 68. Confirmed. Factor out 5, why not? And move it to the other side, please. So negative 68 over 5. And then do this brackety business. Negative 339 over 25. So b equals negative a fifth. Plus or minus 339 over 25i. And just because they may really want it, I'll take care of that. So root 339 over root 339 over 5. So factor out a fifth. So negative 1 plus root 339. And 339 is 113 times 3. And 113 is, drum roll, prime. It is prime. Next up, this. Bring out 3. Just divide everything through by 3. Trust me, you'll be needing it. Then complete the square. That's 8 over 6, which is 3 over 8 over 6, which is 4 over 3. And when you square that, you get 16 over 3. And you've got to balance the book, so you've got to take away 16 over 3. Sorry, take away 16 over 9. And then add that onto both sides. Which is done. Okay. Discriminant was done. Completing the square was done. Now the quadratic formula. Solve via quadratic formula. Right, let's see how fast I can do this. So as a reminder, the quadratic formula says x equals minus b plus or minus square root of b squared minus 4ac over 2a. You know, I'll just do 10 of these. Because it really is just plug and chug. B squared like that. Yeah. So 4 plus 32 is 36. So it's minus 2 plus or minus 6. And all of that's divided by 2. So minus 1 plus or minus 3. Which is negative 4 or 2. I mean, over here, I mean, you can just see it. It's k at 6 times k take 1. But if I just show you the quadratic formula in action, so minus 5 plus or minus the square root of b squared minus 4 times 1 times negative 6 all over 2 times 1. And inside there, we've got 25 at 24, so that's 49. Root 49 is plus or minus 7. So it's minus 5 plus or minus 7 all over 2. So minus 5 plus 7, that's 2. Minus 5 minus 7, that's minus 12. So you can clearly see, when dividing those by 2, that there. So these are insanely obvious. So You know what? How about I get some experience with seeing how the calculator does it. Anyway, just do a few more here. Just put everything in brackets so you won't mess up with substituting. B squared and then minus 4 times A times C, and then all of that is divided by that, just like that. And underneath here we've got 25, take away 24, so it's plus or minus 1 when we square root it, and that there is 5. So 5 plus or minus 1, and then all of that is being divided by 4. Okay? So 5 add 1 divided by 4 is 6 over 4, which is 3 over 2. And 5 take 1 all over 4 is 4 over 4, which is 1. And we're going to, let's see. Mm-hmm. One plus 8 13s, which is 104. So 105. So 1 plus or minus the square root of 105 all over 4. And what is that? Oh. Yeah, as far as I'm concerned, that's finished. All right. So that was a good session. Come back shortly.